This is the energy of a tossed ball lab. Please read through the introduction and also finish the preliminary questions first. Then we'll go into the lab section. First, I need to measure the mass of the object that I'm using. So for this lab, I'm going to use the soccer ball. Place the soccer ball on the balance and it is 438 grams. Record that into the data table. So first I place the motion sensor on the table, then I have the soccer ball ready, connect the motion sensor with my computer. So everything's set up. What I'm going to do is I'm going to place the soccer ball about 25 centimeters above the motion sensor so it can detect there is the ball right there. And I'm going to start the lab by tossing the ball up. Try to make sure the balls go up and down, straight up and down. So I'm going to catch the ball when it's on the down flight. Get it start. First trial, place the ball on the top of the motion sensor and try to toss it up and down. Here is the two graphs that you will be seeing. On the top, it is a position versus time graph. On the bottom is a velocity versus time graph. Let's take a look at this graph. After 7 seconds, you can see the line on the top, the position versus time graph. The position start changing, getting bigger, bigger, and bigger, and reach to a highest point and then start dropping. So that actually represents the motion that the ball from release to all the way to the top, then the falling motion, then to the moment that we catch it. Now let's keep going deeper, dive into the data points that we need. First is releasing point. As you can see, from 2 seconds all the way to 7 some seconds, that's the moment I'm getting ready to holding the ball around 1.8 meters above. So I'm going to pick at this point 7.40. So time is 7.40 seconds and the height is 0.188 meter, which means the ball was 0.188 meters above the sensor. Now take a look at the velocity, 7.40. Velocity at this moment from the device, it shows as 0.001 meter. At that moment, because this number is so small, we might actually just can ignore that. So if you would like, you can just write 0 at that moment for the velocity. Now we need to find a point between release to the top. What I'm going to find is probably this point 7.80, which also helps your calculations a little bit easier because as you can see, 7.80 seconds, the soccer ball was 1 meter above the motion sensor. So 7.80 seconds. The velocity at that moment is 2.408 meters per second. Now let's find the top of the path. Well, when top of the path, the easier way to find is going to find out what is the highest point, which is also the greatest position or the displacement. So it's right there at 8.06 seconds because right down the top, it is 1.299 meter above the motion sensor. So take a look at the velocity also, 8.06 seconds. It is negative 0.104. No, actually this is wrong. 0. Yeah, we can use 8.04 seconds. So on the top, it is about 1.299 meters above the motion sensor, and the velocity at this moment is 0.101 meters per second. relatively, as we talk through the whole progress, when the object on the top of the peak, right before it starts falling, the velocity at that moment should be 0 meters per second. So that means in the experiment there is also human error in there. So at this moment, what we're gonna still use is just use using 0 meters per second as the velocity when it's on the top of the peak. Now let's move on to the data point next, is between the top and the catch. So what I'm going to use is 8.26 seconds-ish. 8.26, which is the soccer ball is 1.092 meters above the motion sensor, and at that moment the velocity shown as -2 meters per second. Now right at the catch, so I would say I'll find out what is the lowest point with velocity closer to 0. The velocity closest point to 0, it's around 8.64 seconds. So which that kind of indicates that's the moment the ball was stopped that I caught them. I caught the ball right at that moment. So it is 0.335 meters above the motion sensor. And still, as we're looking at when the ball was caught, when it stopped, it should not have a velocity on it. So that's also a human error right there, which it is shown as 0.060 meters per second. But for our data points, well, we can just use 0 meters per second for that. So here's the data table I filled in. Later on, I will scan that page and share that also with you. So now these are the data points you need. Think about how can you use that to calculate the potential energy and kinetic energy, and then calculate the mechanical energy at each data point. Just make sure for this lab, I would love to have you to keep at least 3 to 4 decimal places, so that way it's more precise and the result will be more accurate.